All right, hey guys, I'm gonna do one problem from your homework tonight. This one comes kind of late in the problem set. It's page 22, number 13. Now, you're gonna be dealing with this diagram in about 3 or 4 proofs, I believe. So they just show you the diagram once. That's why it's important for each of these, like this is number 13 right here, that you redraw the diagram, right? Redraw the diagram. The reason why drawing the diagram is important for each proof you do is even if you're using the same diagram for multiple proofs here, you're going to be given different premises. You're going to have different given premises here, even though it's the same given diagram. So with the given premises, it's really, really helpful to understand what you need to do in the problem by marking it up first. Here's what I mean by marking it up. We know that our distance RQ is the same as distance TP. So I can show that RQ by just kind of doing this right here. It gets a little bit ugly. RQ, our beginning kind of gift from the math gods is that RQ is going to be the same length as TP. So it just kind of helps you like identify what's on your diagram and how they relate to one another. So we know that that segment here and this segment here are going to be congruent to one another. So a little messy. And we also know that ZQ is equal to ZP. So I can mark that one up maybe a little bit more cleanly right here using green. ZQ between those 2 points here. So 2 tick marks are there and 2 tick marks are between PZ. So I know that that part and this whole are going to be the same as that part in this whole. What is it that I need to prove? Well, I need to prove that RZ equals TZ. So distance RZ is right here. And I'm going to do that in gold because our goal is to get to the gold here. And our goal is to show this. RZ, I'm going to put a question mark double below it here. And it's going to be the same length as TZ, put a little question mark below. And I think we can prove that, right? Because we have a part congruent to a part and a whole, which is the same length as a whole. So kind of through subtraction, right? Through subtraction, we should be able to prove this, right? This and this are the same. This and this are the same. These two, they kind of have to be the same, but we need to string it together with a chain of reasoning, and that's what we're going to do in this proof. We're going to do it in a second. I have up in front of me here pro tips for proving facts before we actually prove this fact that if we have this, then this needs to be true. Even before we prove that, in 2-column form, recommendations for you to make your life so much easier and really just get better. I just see people getting better at this if they follow these hints. So please, I've done this for a few years right now. Please follow this. I can't require you to have graph paper or grade paper this year because of the distance learning arrangement. But if you have access to it, if you can get it, your life's going to be made so much easier. The work's going to be a lot more clean. You're going to learn a lot better. So use grid paper, right? Use graph paper to keep yourself organized and keep yourself kind of sane as you're looking to work here. Draw the diagram. It just takes 2 seconds. So I just grab these pictures from the book, so I don't need to draw them, but boom, boom, boom. Draw the stuff you care about, right? You don't have the label point S. It's not even the problem here. But anyways, draw it out because then you can sketch what you know and you can see what you prove. You can get into the diagram. You get to know the diagram, right? Geometry, part of what you're doing here is getting used to working with diagrams, analyze diagrams, breaking down diagrams, getting ready to use diagrams in the SATs, getting to use diagrams on other things that'll be thrown to you. Business school, you'd have to take exams for business school too, and other professional fields too. So get used to diagrams now because if you're going to pursue some of these fields, you're gonna appreciate knowing how to work with these pretty well. Okay, so draw the diagram, write the given and prove statements. Just by writing this down, right, you're spending less than a minute to do the diagram and write it down. You're familiarizing yourself with the letters and what it is you need to prove. Okay, marking on the diagram with what you know is a great way of telling me that yes, I know how to prove this. And I think I see this here, right? Parts and wholes. I'm going to use segmentation postulate for some reason. So you're kind of thinking through the game plan of this as you're marking it up and how you can see it here. All right, let's get back to the basics, how we're kind of going to do this down here, how we've been doing it all along. Remember, proofs right now in the 2-column form. So you want to start this with 2 columns, okay? Grid paper 2, use that space, buddy. Use it. I don't want to see your homework be like only a quarter of a page long because use the space, use the room. We got statements here. We got reasons over here, and let's go ahead and prove this out. Statement number 1, going to be the same in like 90% of your proofs. That's right, my friends. Who's got it? You got given. All right, might as well put down the 2 given premises and see where that leads us. We got RQ equaling TP, and we have ZQ equaling ZP. Now, it might be far enough along where you kind of know what to do with this given premise right here. Because we actually can write a second step with it. So maybe you've gotten enough practice with this and kind of worked through some of the initial struggle that you had originally and realizing that we can change this around. So let's think about this for a second. This one here has to do with this is a part plus whole type problem, right? This part plus this part's going to equal the whole, right? Going to equal PT. This part here, QZ plus ZR, is going to equal the whole. It's going to equal QR. So we want to be adding, right? We want to be adding at some point here. So maybe you're just adding RQ plus ZQ and TP plus ZP just for the heck of it, because that might come in later. But I'm going to hold off on that. Your book seems to like doing that as a second step. I'm going to hold off on that because it's kind of unclear what to do next, right? We wrote this all out. What does this all mean? We're going to come back to step one later. Okay, that's the thing about these geometry proofs compared to the algebra proofs. Algebra, when you're solving something and proving that x must equal something, for instance, in an equation, you're just doing it in order, right? Step one, we subtract 5 from both sides, and then we have a new equation, subtraction property of equality, right? Then we multiply both sides by 3, we have a new equation, right? Multiplication property of equality. Here we can go different directions, okay? So reminders, this here is called the what? It's called the given premise. All right, we've introduced the given premise here, and if there's something obvious to do with the given premise, you might as well do it, right? You might as well move it around, change something, because this obviously isn't going to be enough to get to prove this here later, okay? We have given premise, and then what's this called again here, guys? This is called the given diagram. So what we've done here is, right, we've done through step one, we have already talked about, we've already kind of putting out stuff here from the given premise. GP right here, GP, okay? We've introduced the stuff from the given premise. Have we built on it? Well, we could, but it's kind of unclear what to do at this point. So maybe we're thinking about the given diagram. What is something we can say about the given diagram? And what's actually something that we can say about the conclusion here, right? About the conclusion right here that has something to do with the given diagram. I know that's a lot. I know that's a lot what I'm putting on you here, but we haven't said anything about RZ yet, about TZ yet. Okay, so remember our goal here when we get done with proving this fact, remember the fact we're trying to prove is if RQ equals TP and ZQ equals ZP in this particular diagram, then RZ has got to equal TZ. This is just a simple logic fact that you're trying to get to prove here. We haven't said anything about RZ yet. We haven't said anything about TZ yet. But look, RZ's in this diagram. TZ's in this diagram. Let's say something about them, okay? I think you get to where I'm going with this, in that my second step, I would do the segment addition postulate, because I can take RZ, right, which is in my conclusion right here, and if I did RZ and I added it to ZP, and that's nice because I got ZP in step one, so they're related a little bit here. And I'm going to set that equal to, right, I got RZ plus, oops, I meant to do not to do ZP. That's not what I meant here. I meant to do RZ plus ZQ, because what I'm getting from my diagram here is that RZ plus ZQ equals what? What do we know about this part plus part equals the whole? It equals RQ, which is up here in that equation. Here, look, ZQ is right there, RQ is right there. That's going to be helpful for us later here. Okay, so that's this segment addition postulate. Okay, is that the only segment addition postulate I can use right now to help me? No, you've been seeing this a whole bunch. Hopefully you get this now. I haven't said anything about TZ yet. I haven't said about TZ yet. So I can say TZ plus ZP equals TP. And there we go. The important thing about doing that is that we have RZ and TZ in here. And look, that's part of our conclusion. So now we got to move those around and figure out how we can prove that RZ has to be equal to TZ. So maybe you're looking up here, maybe you're looking down there, and this is why your book's been having us do this so much, is that, you know what, we can get RZ and TZ equal to each other through various ways, but maybe let's check it out right here. Well, I got RQ, look at this here. I got RQ equals TP, and we got TP right here. TP right here. They're equal to each other. Check that out. Oh, that's interesting right here. So what I can do is I can take, look at this here, RQ. Maybe I haven't noticed it here. I have my eureka moment. This is it. It's a puzzle, right? It's a puzzle for me, Mr. Ford. I've done these props a whole bunch before. The puzzle to actually see it and get it, you get excited. RQ, okay, is right here, and TP is right here. Why is that important? Because I know this. I know that RZ equals RQ. right, equals RQ. So what I can do is I can take RZ plus ZQ and I can replace RQ, right? I can replace RQ. So if I did that and TP, I got TP up here, right? And if I take this, TP equals this right here. Okay, TP equals that right there. So what I can do is I can take TZ plus ZP and I can replace TP in this top equation right here. So I can take these two expressions, this equals that, and that's up here. I can substitute that in there. This equals that, and that's up there. I can substitute that up there. And the nice thing about this, perhaps you see why this was important, is because of this, right? If I do this, RZ plus ZQ equal to TZ plus ZP. Please go back and rewatch the video if you're not seeing how that connects, why that's the case here, because it's a lot. I got excited there for a second. RZ plus ZQ is RQ, right? This is part plus part equals whole from step 2. So this, because it equals that and it's up here, we can take it, replace that here. And the same thing here, TP is up here in this top equation. We can take TZ plus ZP, replace TP with TZ plus ZP. And now we've just simply rewritten this equation with things that are equal to both the expressions right here. What did we do? We did the substitution property of equality. So when I show this with the little arrows here and whatnot, when I'm doing these lectures and getting you used to doing these kinds of proofs, when I'm doing these arrows, is I'm trying to show you I'm taking this and substituting it in. You're going to have the substitution property of equality as your reason if I do that one right there. And again, that was important because, hey, we're kind of tracking the thing we want to prove. And we want to prove that RZ equals TZ. Perfect. The reason why we substituted in there, why I saw that and was like, ooh, that could help us, is because we wanted to get RZ and TZ on opposite sides of the equation. That's ultimately what we want to say at the end here. So let's check it out here. Hopefully, ooh, ZQ and ZP right here, let's hope that they're the same. Are they the same? Are ZQ and ZP the same exact thing? And if we just subtract them from both sides? Yeah, they are, totally. And I get excited. My voice cracks when I get super excited. I'm like, yeah, they are. Look, ZQ's here, ZP's right here. So check it out. Because in statement number 1, ZQ equals ZP, what are we allowed to do? Well, we don't have to show it, but I'll show it anyways. We're allowed to subtract equal values from both sides of the equation right here. So because ZQ equals ZP, we can subtract it from both sides of the equation, and equality is preserved, right? Equality is preserved. And step 4, that's going to get us to the end here of the proof, and we've proven our fact. Is it like a pretty much a very, very useful fact to us here? Is it something we have to memorize? Like if we have these segments of these lengths here, and then it's going to prove that segments of those lengths are the same. No, this is an important one. We're getting used to kind of the flow of this. And these aren't tricky. These are puzzles, right? Getting used to kind of the puzzle solving, which kind of makes geometry exciting, but also frustrating, right? This is one where like I kind of expect maybe like a third of the class to kind of get for homework. And then the next day, right, you're sharing with your groups and maybe you're hearing somebody explain how they got it, right? And see how they got it here, right? We want like this stuff to be like just beyond your grasp of like trying it out the first time and doing it yourselves, because if it's just beyond your grasp, then that means it's a little challenging and you have the ability to like get something that a lot of people don't get, which is like working with your group and really achieving it, right, is a really, really cool thing. So anyways, I didn't put down my final reason right here, but it was right here. The reason was I subtracted equal quantities from both sides. I knew that from step 1. I had said that those two things were equal because it was a given premise. So this is the subtraction property of equality. Okay, and that, my friends, is that for our proof. We got it proven. So we did all this justification here. We laid out all these steps here because now this is a fact, my friends, that when we have if RQ equals TP and ZQ equals ZP, in this given diagram, in this situation, then we know that RZ must equal TZ. Nobody can argue with us because we have all this rules down here. So we could just take that as an if-then statement from now on. We've proven a proposition, right, that Euclid talked about. He wrote about propositions. Anyways, I don't need to get into it. That's it for me, right? If you want to go back and go through it, you can. If RQ equals TP and ZQ equals ZP, because it's given to us, then, right, we can also say that RZ plus ZQ equals RQ and TZ plus ZP equals TB because we noticed it in the given diagram, and it's the segment addition postulate is our reason here. Then through substitution, we can establish that RZ plus ZQ equals TZ plus ZP, because we took what RQ and TP were equal to and substituted them back into step one. Finally, we subtract ZQ and ZP from both sides of the equation, and we're allowed to do that by the subtraction property of equality. And then if we do that, after we do that, then RZ equals TZ. So you can kind of run through the proof afterward to be like, is that logically making sense? And again, your proofs right now are 2 columns, but it's really just like kind of a bunch of if-then statements really in there. And maybe you don't see what I'm saying right now. You'll see it later. And I know this can feel like a lot right now, but trust me, it's good that you're getting a lot of it. You want to get big picture at this point. And you can always correct your answers for homework the next day. It doesn't matter if you can get it for homework at night. The right answer, that is, it's just that you're thinking about this stuff and grasping for it. All right, email if you have any questions this weekend as you're doing your homework. I'm willing to do another one of videos like this. If you're just feeling like there's one you really want me to know how to do, I can do that. So definitely email me. Take care. Have a great weekend. Bye.